Bismillahirrahmanirrahim. Assalamualaikum and a very good day. I bid to all of my fellow friends and doctor. So for the subject principles of heat transfer, course code EAB 3210. Me and my groups will present about heat exchanger in livestock barn. Before we start, I will introduce my fellow group mates. Firstly, Nur Ain binti Khairul Azmi, matrix number 198706. Me and myself, Nur Zahida binti Mahmud 198938. Azmin Isma binti Muhammad Khairunizan 198752. And also Azrin binti Ahmad 197707. Next. Okay, so this is the okay, we start with introduction. As you can see in this picture, in this slide, this is the example of heat exchanger that used in the livestock barn. Basically, a heat exchanger transfers heat from one source to another. Before that, I will explain about heat exchanger a little bit. Uh, a cool a cool fluid and a warm fluid will flow in opposite or cross direction in the heat exchanger. Heat from the warm fluid will dissolve into the cool fluid by conduction through the heat exchanger surface. As you can see in the figure, uh, this type is 100% designed to handle ventilation in summer months. The exhaust air and make up air travel in opposite direction through the core, and heat moves between them. Next. And can you move to next slide? Okay, for the problem statement, our group had decided that during the summer season, the air sucked into the livestock barn is too hot and not suitable for the poultry inside the barn. As you know, the chicken poultry in the barn will affect their growth, and also their health condition. Thus, we use this heat exchanger to stabilize the temperature inside the livestock barn. The cool air from the heat exchanger um, will be used to replace the hot air that's sucked in from the outside environment. Uh, Additionally, the barn exhaust air is very dirty since it contains dust, dander, feathers, and so on. So the core inside the heat exchanger, which is the surface for the heat exchange, keeps the exhaust and make up air separate to prevent cross contamination. Next slide, please. So for the objectives of this, we choose to firstly, we will derive the function and the principal work of heat exchanger inside the livestock barn. Secondly, to stabilize the temperature inside the livestock barn during the summer season. And lastly, to provide the suitable temperature condition for the effective growth of poultry, so that this chicken livestock barn will be more efficient for the growth of chicken poultry. I pass to the next presentation presenter.
Okay. My name is Azrin and my metric number is 197707. So now I will present about the heat transfer method in heat exchanger. Here we have picture of two basic design of heat exchanger, which widely used in engineering process. And there are two type of flow that in exchanger. Firstly, we have co-current on the picture on the above and the upper part, and the secondly is counter current, which is the picture So co-current happen when two fluid of different temperature move along in the same direction, which is parallel, and counter current flow happen when two fluid of different temperature moving in opposite direction. So heat exchanger are able to efficiently regulate heat transfer of one fluid to another through wall, partition, pipe or other dividing medium. The heat transfer of two fluid may occur in conduction, convection, radiation or by all method. But for all method, there has to be some certain condition for the method to um, so next is the heat from the fluid that has higher temperature will dissipate into the lower temperature by the process of convection. Just like Zaidah already said, so the convection occur at the surface of the heat exchanger. Next is the usage of counter current flow in the heat exchanger work better than concurrent flow. So basically in the heat exchanger, usually people will use counter current flow because it work better and because when warm fluid or hot fluid travel along in opposite direction, the incoming cool fluid will absorb the heat of fluid from the other side. And as the cool fluid travel along the heat exchanger, it will be heated up. And as more cooler fluid is added, more heat will be absorbed by the cool fluid. This will make the condition of in the bomb cooler and will lower the. And next is the heat transfer performance of counter flow exchanger perform better than co-current heat exchanger and could be up to 15 more efficiently. And for a good ventilation system, will create a good airflow that able to reduce noise and dry off any wet pieces. So by having uh, this air ex- uh, heat exchanger, this can actually also improve the ventilation inside the barn. And here is the picture of example of exchanger. Next, I will present about the heat exchanger working principle. So this is the example of heat exchanger eh, of counter flow of heat exchanger. So the rate of heat flow at any point kilowatt per meter cube of transfers in the following. Firstly, heat transfer coefficient, which itself is a function of the properties of the fluid involved. Fluid velocity, material of construction, geometry, and angle of the exchanger. The, the temperature difference between warm and cool stream. So generally we know that heat naturally flow from higher temperature to lower temperature. So this is how the heat exchanger work in the to exchange the hot temperature into cooler temperature. And warm fluid will flow from cool fluid by conductivity. So total heat transfer Q is depending on the heat transfer surface area A, heat transfer coefficient H, and average pressure difference between the stream strictly the log mean T theta T Lm. So the total heat transfer Q equal to UAT um, and that's all from me. I will pass to the next presenter.
Assalamualaikum. My name is Nur Ain binti Kara Azmi and my metric number is 198706. Okay, now I will present the analysis of heat exchanger. In this part, I will present about the formula used in the analysis of heat exchanger. In the analysis of heat exchangers, it is often convenient to work with an overall heat transfer coefficient known as a U factor. The U factor is defined by an expression analogous to Newton's law of cooling. Moreover, engineers also use the logarithmic mean temperature difference method, which is known as LMTD, to determine the temperature driving force for heat transfer in heat exchangers. Next slide. Next slide, please. Okay. Okay. First thing that we need to know in order to find the rate of heat transfer in heat exchanger is overall heat transfer coefficient U or thermal resistance R. U is related to the thermal resistance R. For example, heat transfer in a heat exchanger involves convection from fluid to the inlet surface, conduction through the heat exchanger surface, and convection from fluid to the outlet surface. As you can see in the first equation, 1 over U times surface area is equals to 1 over U inlet times surface area at inlet equals to 1 over U outlet times area at surface area at outlet, which is equals to thermal resistance. And then R is equals to thermal resistance of convection at inlet plus thermal resistance of conduction of wall plus thermal resistance of convection at outlet. Surface of the wall separates the two fluids respectively. So when the thickness of the wall of tube used is small, the thermal conductivity of the material is high. So the equation 1 can be simplified into equation 2, which is 1 over U equals to 1 over H inlet plus 1 over H outlet, where U is equals to U inlet equals to U outlet. Next slide, please. Next slide. Okay, next is the rate of heat transfer. The rate of heat transfer from the hot fluid is equal to the rate of heat transfer to the cold one. The letters C and H indicate for cold and hot fluid respectively. So in this slide, the equation 3 is the formula of rate of heat transfer for cold fluid, which Q dot is equals to M dot, which is mass flow rates, times C, which is specific heats, times difference in outlet temperature and inlet temperature for cold fluid. And equation 4 is the formula to find the rate of heat transfer for hot fluid. It is same with the equation 3 for cold fluid. So the product of mass flow rates times specific heat is known as a capacity, is known as a heat capacity rate, which the symbol is capital letter C. Next. Next slide. Okay, this is one of the method used to find the rate of heat transfer. As from the research that I made, most of the engineer use this method because this method is suitable in order to find the size of heat exchanger when all the inlet and the outlet temperature are known. As you can see in the equation 9, Q dot is equals to U, which is the overall heat transfer coefficient times surface area times delta T limit, where delta T limit is equals to delta T1 minus delta T2 divided by ln delta T1 over delta T2. Okay, the formula to find delta T1 and delta T2 is depends on the type of flow. As Azin has mentioned in previous slide, the type of flow in this heat exchanger is counter flow type. So the formula to find the delta T1 is equals to inlet temperature of hot fluid minus outlet temperature of cold fluid, whereas the delta T2 is equals to outlet temperature at hot fluid minus inlet temperature at cold fluid. Next. Okay, next, after we find the rate of heat transfer, we can find the effectiveness of heat exchanger. The formula that can be used to find the effectiveness in this method is epsilon equals to Q dot over Q max. Q dot is actual heat transfer rate, while Q max is maximum possible heat transfer rate. The formula to find actual transfer rate is same as I mentioned in the previous slide, where C, the capital letter C stands for heat capacity rate. So the formula is Q dot equals to heat capacity rate for cold fluid times difference in temperature equals to heat capacity rate of hot fluid times difference in temperature. So the formula for max possible heat transfer rate is equals to Q max equals to heat capacity rate mean times delta T max, where delta T max is equals to inlet temperature at hot fluid times outlet temperature at hot fluid. Okay, next. Okay, for pumping power, in a heat exchanger, both fluids are usually forced to flow by pumps or fans that consume electrical power. The power is normally measured in units of cubic meters per hour of airflow per watt of power consumed or cubic feet of airflow per watt of power. Okay, that's all for me. I will pass the presentation to the next presenter. Thank you.
Hello, I'm Azmi Isma and my matrix number is 198752. So in conclusion to our today's topic, which is about heat exchanger, there are three factors that are observed in order to get the best heat exchanger. The first factor that we need to observe is heat recovery efficiency. Heat recovery efficiency is the most important performance factor. It measures how well a heat exchanger recovers heat from the exhaust air as a percentage. So mostly, heat exchangers have efficiencies in between 50% to 80%. So what does the percentage represent? It represents how well the heat exchanger recovers half of the available heat from the exhaust air. And secondly is the airflow range for multi-speed units. So most heat exchangers can adjust the airflow rate between a low setting and a high setting, while larger units may use a VFDs. VFDs represent variable frequency drives, which allow the variable of air speeds without a manual setting. So by selecting the airflow range to match the ventilation requirements as animals grow during the production cycle, VFDs is very a good choice for the users. So lastly is the air moving efficiencies. So this performance factor measures the amount of power of the heat exchanger uses to move a certain amount of airflow. This is normally measured in units of cubic meters per hour of airflow or per watt of power consumed. So a higher number of air moving efficiency, the more efficient the unit is. So that's all from us. Thank you very much.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.